Michio Kaku has said that the James Webb Space Telescope, JWST, has seen 6 huge structures that scientists used to think were impossible. He says this because of his great advances to the fields of material science. These evaluations might give us new ways to think about how to figure out the world. The exposure is both interesting and slightly contradicts current ideas about how galaxies are changing and moving. It is important to keep an eye out for these changes because the fact that such a well-known person supports them shows how important they are. Michio Kaku is an interesting person in science because she is a scientist with both American and Japanese roots. People think of him as an expert in both quantum mechanics and standard experimental material science. Unlike some more skeptical and conservative scientists, Kaku is excited about the amazing long-term effects of the JWST project. He wants to help us learn more about the world, as shown by his willingness to accept new discoveries and share them with the public. The fact that this well-known analyst broke his silence to say what can't be ignored is great news. It's easy to feel how excited he is when he talks about what the JWST has found. This shows that this new information has sparked his interest in the universe again. Because Kaku is a thinker, he has always been able to come up with new ideas. He is open to ideas that go against what most people think. For example, he knows that Einstein's theories of relativity and Newton's laws are important, but they don't fully explain how the world works. Kaku thinks that what the JWST finds could help the field of astronomy move forward. But many of his co-workers still don't agree with this point of view, which worries and stresses out people who support the Big Bang and people who don't. However, this only makes Kaku laugh. The JWST has found 6 very large galaxies from the very beginning of the universe. Each of them has more stars than our own Milky Way. They were made only 200 to 700 million years after the Big Bang. The group of astronomers who found these amazing galaxies has named them universe breakers. If proven, they would completely change how we think about the world. These findings show that the early years of the universe were much more dynamic and complicated than was thought before. The idea of how things started tells us that after the first event, the universe was very chaotic. It took millions of years for the first solid things to form, and it took even longer for them to get dense enough to give off light. It was thought that complex formations like galaxies didn't form until much later. Some of the newly discovered galaxies are much bigger than the Milky Way. They are also very bright, which means they are probably making a lot of new stars every year, while our galaxy only sometimes makes new stars. Scientists still don't agree on when the first buildings were built because it's still not clear. One thing is certain. There may have been only one or a few stars at the start, or there may have been groups of stars that eventually joined together to make bigger systems. People used to think that systems that big and complicated could not have existed back then. This makes me wonder if the world is much older than we thought, or if these huge systems formed a lot earlier than we thought. Conservative science still has problems with this model, which makes it hard to explain this situation. Some parts of material science have flatly denied these results and called age predictions into question. They know this, which is why Kaku said, there are different models and old theories that stubbornly persist due to the influence of certain specialists. A lot of these ideas were probably shot down when simple analysis showed how wrong they were. He went on, so, the truth in any science, but especially in physics, lies with the experimenters who test the theory and keep it sharp. In the scientific method, Kaku stresses how important it is to keep trying, revising, and confirming. Based on observations of the universe's growth, an idea of how things came to be was written down in 1927. Based on these findings, we can say that the universe started as a single point that was infinitely dense and has been expanding ever since. People and scientists found it hard to picture a world with both a start and an end at the time. People couldn't understand the idea of a world that would last forever. It's still hard for experts to fully understand it today. But it is important to think about these possibilities, even if the new findings don't fit with what scientists have thought for a long time about how the world came to be. Science has shown over and over that being open to new ideas and re-evaluating old ones are important parts of the scientific method. The same kind of openness is needed now as it was when certain ideas and observations were proven to be true. A good example is that when Einstein was young, people thought that stars and planets were set in space and would not move. But now we know that the universe is moving. Stars move within their galaxies, planets move around stars, and galaxies move quickly through the universe. This amazing new knowledge about the universe goes against long-held views and shows how important it is for scientists to keep asking questions and changing the way they think. The idea of the Big Bang came from the fact that galaxies are moving farther apart, and the distance between them is equal to the distance between them and Earth. This idea, which is called Hubble's law, said that the world was getting bigger over time. This idea seems to be supported by things like cosmic background radiation, the redshift of light from faraway galaxies, and other cosmological patterns. However, it is important to remember that people in the past who thought the Earth was flat and the sun went around it also had proof from what they saw until new events or advances in technology made things clearer. We're seeing a similar thing happen right now. Scientists were hoping that the JWST would answer questions about the Big Bang Theory, but it may have found 6 very large systems that didn't seem possible. This shows that science is always moving forward, and scientists need to be willing to accept new information and rethink old ideas based on new proof. The amazing finds have made us question what we thought we knew and made us rethink some of the most basic ideas about the universe. Redshift is a tool that scientists use to figure out different measurements in the study of the world. The color of light changes as light sources and viewers move away from each other. This is called redshift, which is also called the Doppler effect. To get this, picture hearing a car coming up behind you. It sounds like an engine when it gets closer, but it sounds different when it moves away. The same thing happens with light. As a light source, like a faraway star, moves towards us, it changes to bluer tones. When it moves away, it changes to redder tones. The name for this effect is redshift. Physicists have turned redshift values into rates and distances that can be used to study the world. Still, even a small mistake in these numbers can have big results. The old ways of grading are now being looked at again. The newest findings about our universe need to be looked at to see if they are really based on redshift mistakes, or if some scientists are just rejecting what we know to be true. This question needs to be carefully thought through, and the study data and methods need to be carefully looked over. The fact that measurement methods are always being evaluated and re-evaluated shows that our understanding of continuous inquiry is growing. Many thanks for seeing the movie. We always want to remind you to leave your questions in the comments. Please click the like button and share the video with your friends if you liked it. Also, follow the channel to make sure you don't miss more videos like this. Since you watched, thanks again, and see you in the next one. This call to action gets people to interact with the content, which builds a community of people who are interested in and want to learn more about the current scientific debates. Scientists all over the world are still fascinated and challenged by the study of our universe, which has very large distances and many complicated celestial bodies. Every finding, from the earliest ideas about the universe to the newest ones made possible by cutting-edge technology, changes how we can figure out the universe and adds to what we know. The history and formation of galaxies is one of the most important and long-lasting questions in astronomy. Many stars, gas, dust, and dark matter are clumped together in galaxies, making them look like huge towns. Not only is it important to figure out how galaxies form and change over time, but it's also important to test or confirm ideas that already exist. For instance, the Big Bang Theory, which was first put forward almost 100 years ago, says that the universe started as a single point that was infinitely dense and has been expanding ever since. This idea came from looking at how the universe is expanding and the cosmic microwave background radiation, which is thought to be leftover power and light from when the universe was very young. But new findings, especially those made by the James Webb Space Telescope, JWST, have called into question some of the most important ideas in the Big Bang Theory. Because it is so sensitive and clear, the JWST has found galaxies that look much bigger and more developed than their age would suggest. 6 very large galaxies were found that date back to when the universe was only 200 to 700 million years old, which is a blink in its 13.8 billion year past. The researchers called these galaxies universe breakers because they are so big and bright at such a young age in the universe against what most people think. These galaxies finding brings up interesting questions about how quickly the early universe changed and challenges current models of how galaxies form. The most popular ideas say that galaxies are slowly formed over billions of years as smaller systems merge and gas and stars build up. The fact that these huge systems were around so early in the history of the universe says that galaxy formation is much more complicated and may happen much faster than was thought before. The discovery also shows how important it is for technological progress to change how we think about the world. Astronomers have been able to see parts of the early universe that they couldn't see before thanks to the JWST's ability to look farther into space and collect faint light from faraway galaxies. These ideas give us information about the conditions and processes that shaped galaxy formation in the early universe. These findings have effects that go beyond cosmology. They encourage scientists to look at and improve current cosmic models in order to better explain the variety and complexity of galaxies that have been seen over very long time periods. They also show how scientific knowledge is always changing and growing, as new findings can lead to bigger breakthroughs and new ways to look into things. The study of galaxy evolution is still an interesting field that is changing quickly as scientists continue to look at and make sense of data from the JWST and other observatories. With each new finding, we get closer to solving the mysteries of our past and learn more about the basic processes that have made the universe what it is today.